What is the link between Pythagorean triples and Fermat's last theorem? Imagine a world where simple right triangles hide secrets about the universe of numbers. Today, we're exploring how special sets of numbers connect to some of the biggest ideas in mathematics. Pythagorean triples are sets of three positive whole numbers that fit perfectly into the Pythagorean theorem. This theorem states that in a right triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. For example, 3, 4, and 5 are a Pythagorean triple because 3 squared plus 4 squared equals 5 squared. These triples are like the building blocks of right triangles with whole number sides. They have been studied for thousands of years because they show us how geometry and numbers come together. Now, Fermat's last theorem is a different story. It says that for any whole numbers, there are no solutions to the equation a raised to the power of n plus b raised to the power of n equals c raised to the power of n when is greater than 2. This means you cannot find three whole numbers that work like the Pythagorean triples but with cubes, fourth powers, or higher powers. It's a bold statement about the limits of what numbers can do. The link between these two ideas is that Pythagorean triples are solutions to the equation when n equals 2. They show that the equation works perfectly for squares. But Fermat's last theorem claims that for any higher powers, no such solutions exist. So, the neat geometric relationship seen in right triangles with whole number sides only happens when the exponent is 2. When you go beyond that, the pattern breaks down completely. This connection reveals a deep relationship between geometry and number theory. Pythagorean triples are about the special case where the equation works, creating right triangles with whole sides. Fermat's last theorem tells us that this special case cannot be extended to cubes or higher powers. It shows that the beautiful harmony we see in right triangles is unique to the case of squares. In practical terms, Pythagorean triples help us design buildings, create accurate measurements, and understand space. But Fermat's last theorem is a pure math discovery that proved there are no similar solutions for higher powers. It's a boundary that separates the geometric world of right triangles from the more abstract world of higher powers in mathematics. So, the link is that Pythagorean triples are the only integer solutions for the equation when n equals 2. Fermat's last theorem says that for any n greater than 2, no such solutions exist. This shows how a simple geometric idea about right triangles connects to a much broader and more complex story about the limits of numbers.